All right. So, y'all, the next one we have here is number 5 out of 8.4. And it says, can we write the vector in the form A and B? Okay, so look, y'all, if we're going to try to find the A and B form, let's first see if we can find the A component, y'all. So the A component is what we call the horizontal component, y'all. The way we're going to do that is we're going to take the magnitude of the vector, which is 4, times the cosine of the angle that's been given to us, y'all. Cosine of 30 degrees, right? So y'all, let me do this real quick. Let me come back over here. Let me go to my drive, right? And y'all, I've been sharing this with you guys as we've been going across, right, throughout the semester. But let me see. Oh, come on. Here we go. This is what I'm looking for, y'all. My table of angles. Let me see if I can get this guy to open up. There we go. Okay, so look, y'all, I'm looking for the cosine of 30 degrees. Cosine of 30 degrees, square root of 3 over 2. So this is 4 times the square root of 3 over 2. So 2 goes in there twice. So my horizontal component, guys, is going to be 2 square roots of 3. So right here, I'm going to enter in 2 square roots of 3. Okay. Now, let's see if we can find our vertical component, y'all. The way we're going to do the vertical component, it's going to be 4 times the sine of my angle. So 4 times the sine of 30 degrees, y'all. Let's see, I had just opened it up. Here we go. The sine of 30 degrees, y'all, is 1/2, right? So half of 4 is 2. So y'all, this other side right here would be 2. So I'll come back this way. And let me go back this way right here. So y'all, I got a 2 and a square root of 3. And then here we have a 2. We're going to check our answer. And we got it. And then the next one we had, y'all, was number 13. So let me again copy this one. This is number 13. And let me copy this here. Let me come back to my OneNote. Let me put it right here, and I'm going to drop it like it's. And we're going to see, can we find the angle between the pair of vectors? So, y'all, when we're looking for the angle between the pair of vectors, we have a formula that says cosine of my theta is going to be equal to the dot product of the vectors divided by the product of their magnitudes. So let's do this, y'all. Let's call this the vector u, and let's call this the vector v. So, y'all, I want to find the magnitude of u. Remember how we're going to do this? We're going to say we're going to take 2 squared plus 6 squared. That's going to be 4 plus 36. That's going to be the square root of 40, which is 2 squared, it's a 10. Okay. Now I'm going to do the same thing for the vector v. Okay. And I'm going to take 2 squared plus 1 squared. And that's 4 plus 1. That's the square root of 5. Okay. Now, my friends, to find the dot product, let's do this. If we're looking for, if we are looking for the dot product, the way we do this, y'all, is we multiply each of those components, 2 times 2 plus 6 times 1. So that's going to give me 4 plus 6. That's going to give me 10. Okay. And so now, y'all, when I'm going to look for the cosine of the angle between us, or between those two vectors, y'all, I'm going to take the dot product, which was 10, and I'm going to divide it by 2 times the square root of 10 and the square root of 5. So look, y'all, that's a 5 there. That's 5. Let's see, on the bottom, I got the square root of 50. And let me see, can we break anything down here? Probably a couple of things, y'all. When I think of 50, I think of 25 and 2. And I know the square root of 25 is 5, so that's a 5 right there. That's a 5 root 2, right? So the cosine of my angle, y'all, is 1 over the square root of 2, but we can rationalize our denominator, square root of 2 over 2. So, y'all, if I'm trying to ask myself, the cosine of my angle is equal to the square root of 2 over 2, what would my angle have to be? Again, y'all, I can come back over here and I can say, hey, look, right here, when the cosine of my angle is equal to the square root of 2 over 2, my angle, y'all, should be 45 degrees. Okay. So what I'm going to do is I'm going to come back this way. And right here, my friends, I'm going to enter in 45 degrees. Let's check it. And we got it. Okay.